Next, large samples. Sample size is greater than or equal to 30. Single mean test type 4. Next type. Problem based on finding sample size. We are going to find the sample size. So to find the sample size n, if n is the sample size, then n is equal to the formula is z alpha square sigma square by e square, standard error, and the population standard deviation is known. So n is equal to z alpha square small s square. Suppose they have given sample standard deviation, then just replace sigma by s, that's all, by e square. E is the marginal error, margin error or sample error. Z alpha based on the level of significance. We have the table. From that table we can easily put the value of Z alpha. So first problem, a random sample is drawn from a large number of freshly minted coin. The mean weight of the coins in the sample is 28.57 grams and the standard deviation is 1.25 grams. How large a sample would have to be drawn to make these limits differ by only 0.1 gram, assuming that the standard deviation of the whole distribution is 1.25 grams. We'll see the solution. Given sample mean x bar 28.57. The mean weight of the coins in the sample is second line is 28.57. From that we are having sample mean x bar is equal to 28.57. Standard deviation small s, right? Sample standard deviation 1.25. So population standard deviation, whole distribution, the standard deviation of the whole distribution is 1.25. So standard deviation of population is also 1.25. Then error, differ, drawn to make this limit differ by only 0.1 gram. So error is 0.1. E is. To find the sample size, formula n is equal to z alpha square sigma square by e square. So let the confidence level be 95%, right? Level of significance is 5%, right? So from the table the value of z is z alpha, right? Z nothing but z alpha, which is equal to 1.96. So substituting these values, n is equal to 1.96 square into 1.25 square by 0.1 square, so you will get 600.25. so sample size n is equal to 600 approximately. Next problem, a research worker wishes to estimate the mean of the population by using sufficiently large sample. The probability is 0.95 that the sample mean will not differ from the true mean of the normal population by more than 25% of the standard deviation. How large a sample should be taken? We'll see the solution. Given that the probability is 0.95 that the sample mean will not differ from the true mean of the normal population, right? That is the statement, by more than 25% of the standard deviation. So they have given probability of the difference between sample mean and the population mean, right? True mean of the normal population. So difference between x bar minus mu is not more than 25% of the standard deviation. So 25% not greater than 25% of the standard deviation, population standard deviation sigma, which is equal to the probability value is they have given 0.95. That is what this the statement is telling, right? So probability of x bar minus mu less than, that means not greater than means less than, right? Less than 25% sigma, which is equal to 0.95. X bar sample mean, mu population mean, and sigma population standard deviation. So x bar minus mu is less than 25% is can be written as 25 by 100, that is equal to 0.25 sigma, which is equal to 0.95. So that means we are using modulus x is less than a, means x lies between minus a to plus a. Same idea we are having. So minus 0.25 sigma less than x bar minus mu less than 0.25 sigma, which is equal to 0.95. divided by sigma. So you will get probability of 0 minus 0.25 less than x bar minus mu by sigma less than 0.25, dividing all the inequalities, right, by sigma. So you will get the same, which is equal to 0.95. So probability of minus 0.25 into root n, multiplying with root n with the inequalities, x bar minus mu by sigma into root n less than 0.25 into root n, which is equal to 0.95. So x bar minus mu by sigma into root n can be written as its reciprocal. What is that reciprocal? 1 by root n in the denominator, right? So sigma by root n it will become, right? We know test statistics z is equal to x bar minus mu by sigma by root n. So that is z. So replace that. So probability of 0.25 root n less than z less than 0.25 root n, which is equal to 0.95. That is the equation number 1. We know from the table probability of minus 1.96 less than z less than 1.96 is equal to 0.95, right? That is 5% level. So minus n plus in between, right? So that is equation number 2. So comparing 1 and 2, so 0.25 root n is equal to 1.96, root n is equal to 1.96 by 0.25, that is equal to 7.84. So root n, that is n, which is equal to squaring both sides, 7.84 the whole square, approximately 62. So next method, probability of minus 0.25 root n less than z less than 0.25 root n, which is equal to 0.95. We are taking that step. From that step, this implies this can be written as 2 times probability of 0 less than z less than 0.25 root n, because the area minus 0.25 root n to plus 0.25 root n normal area, right, is nothing but 2 times the area between 0 to 0.25 root n, because the normal curve is symmetric. So we can divide minus to plus. Suppose if you are having minus a to plus a, in between you are having 0. So minus a to 0, the total area between minus a to plus a in the normal curve can be written as area between minus a to 0 plus 0 to a, right? So minus a to 0, the area, because symmetric normal curve is symmetric, so the area minus a to 0 is nothing but 0 to a, the area between 0 to a, both are same. That is why 2 times the area between 0 to a, the same idea we are using. So 2 times probability of 0 less than z less than 0.25 root n, which is equal to 0.95. So probability of 0 less than z less than 0.25 root n, which is equal to 0.95 by 2, that is equal to 0.475. So from the table, 0.25 root n is equal to 1.96. So root n is equal to 1.96 by 0.25. So because 0.475 is almost from the table, it is equal to 1.96. That is why, right? So that is equal to 7.84. So n is equal to 7.84 the whole square, approximately 62, right? Thanks.